we studied neutrinos from the sun. At the time that we began our studies, there was a puzzle. There were too few neutrinos being observed from the sun. Then the calculations that were also calculating, of course, how the sun burns and how the neutrinos are being generated by the nuclear reactions in the sun. What we observed was that the reason why the neutrinos were not being observed is that there was a change in what we call the flavor of neutrinos from the electron neutrino type that's produced in the sun to other two neutrino types as they traverse the sun and ultimately come to the Earth. It means that one has to look for physics beyond the standard model of elementary particles in order to understand the mass, which is finite, for neutrinos. That's the implication of this change. In other words, neutrinos do not behave like all other particles. Secondly, we were able to confirm that the calculations of how the sun burns are very accurate. That's of value because here on Earth, we are attempting to observe, we're attempting to create power from fusion of elements, which is what's happening in the sun. In the sun, the fusion processes, which are millions of degrees, are confined by gravity. On Earth, we try to do that in a magnetic bottle. We try to turn the charged particles back into the bottle without touching the walls because they would melt them. However, the calculations of exactly how this fusion proceeds are very similar to the calculations that you do for how it proceeds in the core of the sun. And so we have provided a strong confirmation for the theoretical calculations that are used to develop fusion power here on Earth, therefore of value more directly to humankind within the next 10 or 20 years.